Hi, this is Lex, and welcome to the FinTech Blueprint. It's your podcast about fintech, decentralized finance, digital banking, investing, robo-advice, artificial intelligence, and all the other frontier technology that is transforming financial services. To get more content, like an illustrated transcript of this conversation in your inbox, subscribe at fintechblueprint.com. Today's podcast is a collaboration with Consensus, the market-leading blockchain technology company. Given its core position in the Ethereum ecosystem, we're able to bring you the most captivating industry insiders, from technologists and entrepreneurs to designers and creatives from all around the world. So join us for inspiring conversations on the future of finance, crypto, and what is making up the new decentralized web. So without further delay, let's jump into today's episode. I'm so excited about today's podcast. We have with us Sergey Nazarov, who's the co-founder of Chainlink and is one of the key entrepreneurs and builders in the DeFi space. And we're going to talk today about what it means to build in DeFi, what oracles are like, how all of this works, and where the protocol is going. Sergey, thanks so much for joining us today.
Thank you for having me here.
Awesome. I'm really excited to jump into the substance. But maybe first we can just start off and ask you, what got you into the blockchain industry and how did you get attracted to the current problem that you're working on?
Sure. So, I've been working in the blockchain industry now for over 10 years. And when I started, the only thing that existed was Bitcoin. And the attraction of Bitcoin was primarily almost as like a gaming digital currency type of thing, or there was a CryptoPunk, cypherpunk community. Those were the two groups. I came into Bitcoin more from the point of view of it as a digital currency, and as one of many digital currencies. One other one that was an example that turned into real money for people was like Wow Gold and Linden dollars and a whole bunch of other things. At the end of the day, the thing that attracted me initially to Bitcoin was its longevity. So the fact that there was no company behind it, because I knew from the history of digital currencies and even digital loyalty point systems, that the common history of digital currencies up until Bitcoin was somebody would make some for-profit digital currency company, it would run out of money and it would close, right? And whatever value was it put into that digital currency was lost because the company closed. And this also happened with various gaming-related digital currencies, either because the company closed or because the rules were changed by the gaming provider. Stopping like
This is what actually happened with Linden dollars, right? With Second Life.
yeah. Linden dollars is an okay example. There was a lot of markets around Wow Gold. There's a lot of these things, right? There's something called Beans, BEENZ, that came out of the first internet boom. And the story is always kind of the same. The story was always, and I knew this history of digital currencies pretty well because I was really interested in it for a long time. I was a user of many different digital currencies, pretty much, I think, from a pretty early age. But I saw people consistently basically getting screwed, like one way or another. So one way was, oops, we ran out of money, the company's closing. The other way was, oops, we have to change the policy. You put in thousands of hours into grinding out digital dollars of some kind, Wow Gold or something like that, and now it's not resellable, or we froze the account, or you used a bot to grind it out and now you don't get to keep it, or like the rules just keep changing. So when I realized that Bitcoin was a protocol and not a company, right, that there was a protocol that was run by a group of impartial node operators, that was a pretty unique difference between every other form of digital currency. And so I started spending substantially more time on it. I spent a few years doing that. I did some mining. That's basically the only thing you could do for those couple of years is do mining related things. Then the first smart contracts started coming out with the first altcoins. Namecoin was the first one, and then there were a number of others that came out. And I was just basically working on the first versions of smart contracts from the time that they basically came around. Because by that point, I had come to the kind of idea, not the conclusion, but the idea that if you could change, the way digital currencies worked into like a trustless node operator, blockchain-based, decentralized way, then what other transactions could you do that for, right? So my question was, okay, you can do this for these like Bitcoin tokens, but can you do it for any other thing? Can you do it for any other data? Can you do it for any other transactions? And I always thought about it as transactions. I always just thought about different categories of data and transactions. It wasn't really about tokens for me at any point. It was more about the properties that a transaction has and the properties that data has. And so the first thing that I worked on that I actually kind of ended up releasing in some form, worked on a number of things before that, but the thing I ended up releasing in some form was a secure messaging system that would encrypt users' plain text client side, and so it wouldn't send the plain text to a server to be stored in an encrypted form on a server somewhere. It would use the blockchain as the data store for the encrypted ciphertext. And so that was pretty impressive to me, because at the time all of these different messaging systems, were being made inoperable in various ways. And the fundamental problem was that they stored the ciphertext, right? They stored the encrypted text of the message and they encrypted it 3 times, or they did whatever they did, but like it ended up not working. Because you could always get the ciphertext and you could always shut them down, and then the service didn't exist anymore. The secure messaging kind of industry is a very specific industry, let me put it that way. And I just decided not to pursue being in that industry. And then I just kind of started building different use cases for different transaction types. And eventually we built a number of different smart contract types, things for decentralized exchange, things for, a number of different things related to proving that goods had arrived, proving that search engine rankings had risen to a certain point, and that would release a deposit to the search engine optimization firm. So like a number of different use cases. Well, then what basically happened is Ethereum came and it owned a part of the stack, right? So Ethereum deserves a lot of credit for innovating in our industry and owning a part of the stack, specifically the smart contract state part of the stack, right? And they did it so well that what became pretty clear to me pretty early on is that there are just going to be winners in certain parts of the stack, right? So there's a decentralized stack, and who wins, who becomes the most secure network effect winner in that part of the stack, right? And then what part of the stack do you want to work on, right? So that's really the question to answer at that time for me. And the answer was oracles, partly because all the smart contracts we had built used oracles, right? So they depended heavily on oracles, and we had a lot of expertise around oracles that at that point I don't think really anybody was building externally enabled, externally connected contracts. Everybody was very focused on colored coins, which is another tokenization format that went out of style for various reasons. But people were very focused on tokenization. And they were focused on certain multi-sig schemes, and DAOs were starting to come about, around 14, 15, something like that. And I was always consistently focused on how do you make more advanced smart contracts, right?
Yeah, this is actually a great place to ask you a bunch of definitional questions, because you've mentioned smart contracts and you've mentioned oracles. And even before that, we talked about transactions. And I think one of the things I think about a lot is the difference between money or value in motion versus money or value at rest. And I guess one of the questions could be, what are ledgers and blockchains and networks for? Are they for movement, for chaos, for this kind of distributed energy of change, or are they for the storage and stability of large amounts of value? It sounds like you have a fairly strong lean towards transactions and agreements and kind of motion types, but maybe we can explore that a little bit and then define sort of smart contracts and how they work within that context.
Yeah, sure, absolutely. So my firm belief, and the reason I've been working on this for so long and plan to continue working on it for a while until the societal change that I think is important is reached through this technology, is that this is fundamentally about changing how people relate to each other and to institutions. So if you look at society, the basis of society is a social contract to begin with, right? So that's why society exists at all. And so that's a contract, right? And that's an agreement. And then on the basis of that social contract, you have a number of other contracts, commercial contracts, contracts with the state, contracts with each other in a peer-to-peer sense. And they all take different forms, right? And so what I see the world as, and what I see, like every object that's in front of me right now on my desk, and if I look out the window, and like everything that isn't from nature, everything that isn't a natural, like state in some kind of equilibrium and just has existed for thousands of years, is a result of people's ability to collaborate and agree. And that includes everything, right? That includes ad networks, global trade, the games that people play, the fact that they have a TV delivered to their house, 50,000 other things. That for me is kind of the basis of all those things. It's that people are able to collaborate and agree. And historically, what you've seen, on a consistent basis is the better people are able to collaborate and agree, primarily because there's a system of contracts, right? So throughout history, there have been kind of like economic zones where people could agree, right? Where they could collaborate. So Rome was a good example of this. The English Empire was a good example of this with the invention of corporations, right? The United States is another good example of this, right? Where people can collaborate and agree efficiently. And so they're able to achieve all these things. And what I think all of this is about is it's about value, and it's about transactions, and it's about data, it's about all those things. But at the most fundamental level, what it's about is how society works and how people work with each other, and really how everything works, except now it's backed by a technology. So what did information technology do? Before information technology, IT, there was information, right? There was information in books, there was information in, various formats. And then information technology, right? Basically computers and Internet 1.0 and Internet 2.0 changed people's relationship with information, right? So people are constantly on their phone looking at information. People are constantly interacting with each other, sending each other information. And, that is a huge step function, orders of magnitude shift in how the world works, because the technology was applied basically to information, right? How does information interact with people? How do people interact with information? How do they generate it? How do they store it? How do they communicate with each other? That's also information. This is information, right? We're generating information right now using information technology. People are going to consume this information using information technology. And what blockchains are trust technology. And just like people would sit around and say, hey, do I really need information technology? Like I have a library down the road, and I have a newspaper, and I have the postal service. Do I really need telecoms? Like, do I really need an iPhone? Do I really need a Zoom call to do work? The answer is, do you need it? You probably don't need it, but after you have it, it's like walking places instead of driving there, right? So it's just the way the world works. And I think it's the same situation with blockchains, right? So with blockchains, every time I see people go like, blockchains are about tokenization, and blockchains aren't useful, I basically see people sitting there with a clay tablet or something and saying, hey, we're not interested in paper. I don't need paper. I got my clay tablet. Or they're sitting there with paper and they're saying like, oh, computers, that's never going to go anywhere. I'm never going to have a computer in my house. Like, I like books. I like paper books. Okay, that's fine. But the vast majority of information is now consumed through information technology. So I think it's about all those things you said, but it's actually about changing how trust of everything works. Trust of interaction with political organizations, trust of interaction peer-to-peer, trust with the financial system, trust with global trade, trust with ad networks. And the rebuttal to this would be, hey, there's no problem, there's no trust issue that this stuff solves. Like, that's the only viable rebuttal. And the answer to that is, well, let's pick an industry and let's find some trust issues, and let's ask how the current world solves those trust issues. And the answer, about 90+% of the time is, well, it has no way to solve it because the current model has tapped out. Like you've basically driven the centralized Web 2.0 model, whether it's for finance or whether it's for ad networks or whether it's for any even personal data storage, like your own personal images, or you don't want your data mined. Okay, like it's all hit a limit, right? It's just the marginal utility, the marginal increases of how much more you can do with it has hit a limit. And this is the new thing. This is like going from clay to paper, or it's like going from paper to digital. This is the new thing that has so much farther to grow on all these dimensions.
We're definitely cranked up to 1,000,000 on the attention economy and sort of the logical power laws of the internet, with multiple companies being worth over, $1 trillion or $2 trillion and subsuming entire industry sectors and creating some pretty perverse social and cultural outcomes. I think this is also a good place. You talked a lot about information, and information, I think, is the substrate in which we render our societies, our corporations, our organizations, right? And the sort of the more flow there is between us as individual people, the more sort of we can construct in this abstract conceptual space. And then we gotta pin it down into different media. And so the question is, we've got very different media. We've got still the libraries and the paper books. We've got still the centralized databases, and most of our information architecture is about Web 2 and cloud and things of that nature. And that's a little bit orthogonal to how blockchains work, which start from a place that's quite different. They start from the protocol and then build up verification and computation from there. So can you talk a little bit about how oracles are kind of the glue between these different worlds, and then your approach to what it is that you started to build?
Yeah, sure, absolutely. So everything you describe about the real world, as far as its digital data, has a lot of value, right? Because it proves a lot of things about the world, and there's all these different systems generating proof about what's going on, right? So either it's proof about market events, it's proof about weather, it's proof about any number of things. So the place where we started solving the Oracle problem was how to generate consensus and decentralization about the non-deterministic outside world and bring it as close as possible to the deterministic blockchain world, right? So the blockchain world gives you these certain guarantees about, private keys signing things and transactions working in a completely predictable way. So they're hyper reliable. And this hyper reliability is kind of their main property. And it includes being tamper proof, and it includes being censorship resistant, and it includes it includes all these other properties, right? You can just view it as the thing is going to do what it says it's going to do every single time. Nobody can suddenly stop my trading like Robinhood. Nobody can suddenly become insolvent like Evergrande. Nobody can suddenly fake an audit like Enron. Like, that's probabilistic, and blockchains are deterministic. Blockchains guarantee you that certain computations will happen a certain way. And so that unique property is what we have applied now to many different categories of data. So different data from markets, different data about weather, different data about sports, data about elections, data about any number of topics. And as we make that data what we call validated, right? So it's validated data in that it has achieved a new level of reliability and validity. That data now acquires this hyper reliable property. And once it acquires that hyper reliable property, it can be used for two things. It can be used for powering smart contracts, right? Which has been the missing piece in this industry, in my opinion. It's been the ability to power a smart contract with something other than a private key signature or something other than a token movement, right? So what are the inputs? What are the conditions? What are the events that the smart contract is about? And if you're going to engage in hyper automation with a hyper reliable system, then whatever system controls that needs to have those same properties in order to maintain the smart contract's key value, right? So it's really a friction between, hey, we want to expand what smart contracts do into what we call hybrid smart contracts that interface with the real world and therefore can be written about global trade, ad networks, insurance, derivatives, lending, 50,000 other use cases that existing smart contract without this hybrid capability, wouldn't be able to be written about. And so you want to expand that functionality, but you want to maintain the hyper reliability of what you now define as a smart contract, right? And actually, to your question of defining a smart contract, it's actually a definition that continues to change. So when I came into the industry around making smart contracts, the initial definition I had was that it's a tamper-proof digital agreement that can verify reality, right? That can verify real-world events. So that was my definition. That's the sense in which it was smart, right? It was smart in that it knew what was going on. And then the entire industry kind of really shifted to tokens because tokens was the functionality, but I just kind of stuck with that definition. And even if architecturally you look at what defines a smart contract, in the early days, it would probably be one piece of code, right? So it'd be one smart contract. And then it expanded to be two smart contracts, the main contract and the multi-sig. And then it expanded to three contracts, the main contract, the multi-sig, and the DAO voting scheme. And then it expanded to those three on-chain contracts and an off-chain Oracle network that powered it with events. And now it's actually expanded to multiple Oracle networks, right? So we have smart contracts that use the Chainlink networks, of which there are hundreds now, going to thousands, I think pretty soon. We have smart contracts that actually use multiple Oracle networks for different data, and they use an Oracle network for automation through something called keepers, and they use an Oracle for something like random number generation. So you actually start to see a definition now where a smart contract, from an architectural point of view, is very similar to a web application, right? If you were to say, define a web application to me, well, a web application would probably be defined as tens or even hundreds of different services, external and internal to the company who built the application, all working together to create certain user experiences. And that's the design pattern we're now seeing for what defines a smart contract. So what I think is going to define a smart contract in the long term is a number of different services, some of which are on-chain, some of which are off-chain in an Oracle network trust minimized format, and some of which are on different chains. So I actually think that the next step for smart contracts is twofold. One is there's a bunch of off-chain services, random number generation, automation through keepers, multiple data networks. Then there's the use of multiple contracts on other chains as services. And it's this collection of services between trust minimized off-chain, on-chain, and on-chain on other chains. And now that's the definition of a smart contract. And so the definition of a smart contract really just continues to expand as people can build more and more capabilities through more and more services, decentralized services. And that's really what Chainlink's goal is. It's to provide that universe of thousands, eventually millions of different decentralized services that enable trust minimized off-chain compute for certain keeper tasks, trust minimized data retrieval on different topics, trust minimized cross-chain movement and commands through the CCIP, messaging protocol. And we've already seen this with DeFi and a number of other verticals. Basically, the rate at which we're able to put data on chain, the rate at which we're able to provide decentralized services, is the rate at which many application types end up growing and coming into existence. And this is why we power anywhere between 60 to 80% of all of DeFi, depending on the day. And in certain verticals like decentralized lending and DeFi derivatives, we often power pretty much over 90% on a daily basis, day after day, because those systems require an Oracle network. And so our goal is to provide just more and more of these Oracle networks run by these decentralized node operators to apply this consensus method to more and more services, right? And as that decentralized consensus of an Oracle network is applied to more and more topics, right? Whether it's certain types of compute, whether it's cross-chain, whether it's data, that kind of application creates more and more hybrid smart contracts. And really, if you think about it, I think hybrid smart contracts are what the vast majority of smart contracts will be, because that's what DeFi is. DeFi is a hybrid smart contract. That's what decentralized insurance is. That's a hybrid smart contract. So all the use cases that have the biggest global industries and are just now really starting to take off on a blockchain are all hybrid smart contracts. Tokenization and representing ownership on a ledger, that's great. That's a great thing, and that's a great starting point, and it's gotten a lot of value into this format for those advanced hybrid smart contracts to interface with. But if you look at global, value generally, ownership is a big deal, asset registries and stuff like that. But it is not as big as derivatives, which is a multi-quadrillion-dollar annual market. It's not as big as things like global lending and global trade, just because those are the things that power how the world works on a daily basis. And so that's what this is all really about. It's transitioning blockchains and this trust technology into all of these other use cases through the existence of these services. And then beyond that, it's the creation of an abstraction layer. And then over time, it's the creation of what we call the truth machine, which is what proves things to people and even to society eventually. And the truth machine will become, in my opinion, very much in demand as society becomes increasingly tired of centralized systems promising one outcome but delivering another. So promising your ability to trade, but not allowing you to trade, or promising solvency as a real estate developer, but not providing solvency, or promising an accurate audit, but not doing an accurate audit. And those examples are like Enron, Robinhood, Evergrande, and there's going to be many more examples like that. And so the truth machine is what's being built alongside and underneath all of this on many different topics. Because where are you going to get definitive, cryptographically proven truth on many different topics? Well, you're going to get it from an impartial, decentralized, hyper-reliable system that already powers tens of billions in value the way that we do today. And so that's really the thing that's being built here in the long term.
Yeah, that's fascinating. There's so much in there to respond to and pull apart. I'm noticing it's an interesting thread in your thinking, in your framing of society as it's a very optimistic and rational thinking, in that society is based on the social contract. You've got these positive rights that people negotiate, certainly for any of their transactions or things that they willingly enter into. And so that's an interesting ideal about the dynamics of power. And then I think there's also something deeply optimistic about the idea of there being a truth machine, of there being a thing that is binary, in a sense of saying, this is true and this is false, this you can trust and this you can't. And I think it points definitely to like an existential betrayal that many of us have experienced as we've seen technological systems go from promises and utopian framings towards some pretty perverse outcomes for the human condition. But there is this optimism that like there is there underneath the false promises, there is an actual fact. Can you talk about that a little bit more, especially as we start thinking not just of conditions within software or particular data streams, but maybe more broadly? Like, how do you think about that? Where's that coming from?
I mean, it's coming from me seeing it be possible to use trust technology to solve problems that centralized information technology systems have been unable to solve for 40, 50 years. And really, this realization came to me just when I started working on this stuff. And even that example with something like CryptoMail or some of the DEX related transactions, there are decades of people trying to figure out how to reliably message something without storing it in a place that an adversary can go get the ciphertext. There are decades of people researching, how do I make a deterministic, reliable agreement on some kind of topic, between the fields of contract theory, the fields of game theory and econometrics and economic analysis, and computer science. And I think the reason that I've devoted so much time and energy to this endeavor and to this industry is because I see it work in a small form, right? So I've basically seen a light bulb burn for like 10 minutes. So I've seen the light bulb filament in a vacuum be able to burn. And everyone is still like thinking about, hey, how do we make slightly better oil lamps? And how do we transport the oil for the oil lamps? And look, I have a great cover for my lamp that has oil in it. It's going to revolutionize like how lighting works, or how people work into the night or something. And it's just that simple, right? I've just observed it and I've seen it work in terms of securing data and in terms of making agreements that are pretty much unassailable by anybody. And the fascinating thing is what this does for, you mentioned the dynamics of power, right? The dynamics of power are kind of monopolistic in many cases, right? Where you're a big supplier and you have big supplier power, or you're a big purchaser and you have big buying power, and everybody, who you're buying from is largely beholden to you. Or even some of the stuff that happens in society in general with certain promises from certain technology companies about, hey, we're great, we'll allow you to do whatever you want in this category of activity whenever you want, right? And we're solvent. We've been around for 100 years. We secure a couple of $100 billion in value on our books with real estate, and like it's just clear to me, right? Like I keep seeing like some oil lamp somewhere explode and put a house on fire, and everybody's like really sad. But I just saw a light bulb work, and the incremental increase from a light bulb, like how much more can you improve oil lamps? Can you really improve them that much more? You've been improving oil lamps with information technology for 40, 50 years. You still have people lying about solvency and creating global economic worries. You still have people halting trading despite 50 times promising to allow the exact activity they halted. You still have people conducting audits on things like Wirecard, which is like one of the top fintechs in the past, right? Wirecard, super duper fintech, super duper oil lamp thing. Wow, look at it go! Like one of the best fintechs in Germany, one of the biggest markets for fintech stuff, and the whole thing gets taken down because an auditor didn't do their job on an annual basis. I mean, I don't know. It's pretty clear as day to me. I think the thing that people don't don't see is the light bulb, right? They haven't seen a light bulb turned on, or they might have seen it and they thought it was a novelty, but there haven't been enough problems with like oil lamps or something, right? Like there haven't
Yeah,
like the
it's just magic, right? It's just magic to people, and so they don't understand the mechanics. Maybe if we can just narrow down to a really simple example of the types of things that you started doing probably 2 years ago or earlier, right? Like let's narrow down on the problem of I'm Compound or Ava, and people want prices for some particular holding. How does Chainlink plug into that? And then what is the actual sort of like the nuts and bolts of how these two things work in terms of the integration and the plausible and truthful data that you provide?
Sure, absolutely. So just like blockchains generate consensus through multiple independent node operators, multiple independent computing systems, agreeing on a final result, we have multiple independent node operators that verify data about, in the examples you gave, let's say crypto market data or maybe other types of market data. And we have hundreds of exchanges covered through the top data providers out there in the world, and we have tens and probably going to hundreds of nodes at some point verifying the specifics of that value, so verifying that that's the value that is the global price or the accurate single source of truth that's cryptographically verified and proven to come from all these places and to be accurate. And that's done at such a level of quality that we're already securing anywhere between 40 to 60 billion across all Chainlink networks today. And at some points it jumps well above that, depending on the amounts in various DeFi and certain CeFi protocols that use us. Integration with this is actually very simple because it's on chain and it's accessible by various smart contracts that can simply request the value and pay a certain amount of link for that. Beyond that, we've actually started to see a number of CeFi users. Basically, as the speed of the consensus and as the quality of the data generated from these Chainlink Oracle networks continues to improve, you actually see multiple CeFi applications, such as Celsius and others, who have very security sensitive user bases, right? The user base is the crypto community user base. And that user base actually values that even a more centralized system that's gradually becoming decentralized is triggered in this way. So what I actually think will happen is that over time, as people begin to demand more cryptographic promises, right, more cryptographic truth and less paper promises and less, I wish it could have been different type of promises, everybody will start to ask how guaranteed even certain centralized systems like fintechs or banks or other things are. And then integration for them will be just as simple, and the amount of nodes and the amount of data sources will grow, right? So the way this works from an economics point of view is that the fees from all the different users are aggregated into pools for each Oracle network, and they're consistently used to pay for better nodes, better data. So as more and more users use each Oracle network, their fees basically participate in a kind of shared security economics model where each additional user improves the security for themselves and every existing user of that network. And what I fully expect to happen and already see happening is that as more users utilize certain Oracle networks, right, whether that's for random number generation, whether that's for compute, whether that's for data, their fees will grow the size of that network in terms of its security. And then every subsequent user that comes into that vertical or into that category of applications and has to decide how they're going to get that off-chain trust minimized computation or that off-chain trust minimized data or that cross-chain trust minimized movement or transaction or command, they're going to be faced with the choice of, hey, do I bake my own? And what could I bake? Okay, I could bake maybe an Oracle network with 7 nodes, or I could bake an Oracle network with 16 nodes. Or do I use this Oracle network over here that's been used and validated and reviewed by hundreds or even thousands of the top applications, and they're all paying into it, and that Oracle network is going to keep growing from hundreds to maybe even thousands of nodes on that topic, right? So it's actually not just the consensus, and it's not even just the data quality. It's the ability to create an aggregation of security and to create long-term economics that benefit all the participants and users of that specific Oracle network.
So if I'll pull out a couple of things from what you said. The first is, just as with, there's sort of a straight up point, which is, just as more people mine Bitcoin, the network is harder to attack. So similarly, in a crypto architecture, crypto economic architecture, you end up with these network effects that the more that people use it and support it through their consumption and fee payment, the more the product becomes more secure, more decentralized, and therefore more trustworthy. So that's kind of one thing. And then the other point is that this is really like a superstructure. Like, this is a reformatting of a solution to a problem, and companies like MSCI or S&P, right, like large providers of chunky data pipes and so on. This approach, the protocol approach, is a reformatting of that answer and potentially has some pretty powerful. It's evolved into a format that's a lot more powerful for the next generation of software and technology development. We're coming up on time, but I do want to ask you kind of one last question around the future structure of protocols. And I see right now, especially around DeFi and the sort of memes about DeFi 2.0 and so on, I see a tension between some of the early story of the crypto economies, such as, everybody's self-sovereign and we can go and be liquidity providers and we can be market makers and we're our own bank type of thing, which sort of presumes that every actor is the agent or is like the point of capital or the point of decision. And then there's some forces now which are kind of, they're aggregating all of these things together, right? So it is more efficient to provide liquidity as a group because you spread out risk rather than to do it all individually. And so we're starting to see, I think, some of these tensions between the early promises of the space and the types of economic shapes that protocols are taking on. And so from your seat, do you think that it's a sort of, you're going to have horizontally integrated layers, like maximally broad layers for oracles and data and so on, such that there's a power law to a winner take all market? Or are we going to see still a lot of individuals? It's still going to be sort of like massively atomized the way that it has been?
Yeah, so I think what our system does is two things, or what the kind of system that powers the economy of Chainlink seeks to do is two things. One thing is to generate more security for higher value securing networks as they secure more value, and that's something we've already been able to successfully do. And the second one is the long tail, right? The long tail of computations and data and all these other things that there isn't a big user base for, but that needs to come into existence in order for that user base to appear, right? Because there's a chicken and egg problem between, hey, I don't have the computation, I don't have the data, I don't have random numbers. How can I build a fully decentralized application of a certain type? And this is a problem that we have solved for DeFi early on, and part of the reason DeFi grown to where it is today. And this is a problem we're very focused on that long tail. So I think that there will be networks that secure huge amounts of value, tens of billions of dollars is already secured by certain networks, and they will continue to grow in security, and they will continue to add really high quality node operators, and their user base will continue to grow. And so their security and decentralization will continue to expand. And then there will be a long tail that is a big kind of hotbed of opportunity for various data providers. And we have many, many different data providers going live with us. AccuWeather is a data provider, a number of other top data providers in many different fields: sports data, AML, KYC, identity data, a whole bunch of categories of data. And this long tail is what we need to make efficient, right? So we need to make it pretty efficient for the long tail to exist and be accessible by a multitude of different applications. And then, very importantly, the long tail, the applications that get made in that long tail of all the computations and data and cross-chain smart contract architectures that initially only have 2 or 3 or 5 smart contracts or dApps building in that whole ecosystem. Once they grow to 50 dApps, or once they go to 100 or 1,000, right? Once they have like their DeFi moment or their NFT moment as a vertical or as a category of smart contract, the Oracle network infrastructure needs to scale with their security needs, right? So you need to constantly have the long tail to generate all of those innovative use cases, such as decentralized insurance, dynamic NFTs, fraud-proof ad networks, so on, and so on, as well as the ability to migrate those initial smaller implementations into high security, hundreds of nodes, tens of billions of dollars secured in a single network architectures, right? And those are the two things that our system already does and is going to be getting better and better at, because that's what it's really architected for. It's not just architected to provide a long tail for MVPs or early applications, and it's not just architected for, hey, we need this really secure Oracle network for 1,000 users that collectively secure, like, let's say, I don't know, $1 trillion. It's architected to actually create a consistent pattern of growth for the entire industry, vertical by vertical, by providing the long tail of services that aren't yet in demand efficiently, and being able to convert that long tail once a specific vertical becomes successful enough to demand higher security. And that's what will also allow that vertical to grow and secure more value. Is it'll have a secure chain, but it'll also have a secure off-chain computing system for data and cross-chain and all these types of decentralized services. And so that's that's the two things. And in both of those, there are different players and different node operators and different data provider participants. But in both of those areas, there's room for everybody. And it's I think a very big land of opportunity for enabling various decentralized applications as a data provider or a node operator, and so we actually see that more and more. We see more and more, even enterprises, after doing the analysis on the Chainlink ecosystem and the Chainlink economy and the economy around hybrid smart contracts. We see enterprises like Swisscom and others decide that this is a worthwhile endeavor for them to spin up a team on and actually pursue as a line of business, because the economics add up. And those people, they do serious analysis when they consider spinning up a business unit or spinning up a team that's going to work on something. So I think it's going to continue in this way.
Awesome. Thank you so much for painting that vision for us. And I really appreciate the detail and the kind of the color that you've laid out for where Web3 is going and what it's going to turn into. If our listeners want to learn more about Chainlink, where should they go?
On Twitter, we're active on Twitter/Chainlink. Chain.link is a good site with a lot of stuff going on. We consistently have hackathons, and we have a lot of videos about how to build smart contracts. And we're putting out greater and greater amounts of research about smart contracts on our blog. So I think between our blog, Twitter, and the many events that we put on to get people to build advanced smart contracts, all of those are great resources.
Awesome. Sergey, thank you so much for coming on the podcast today.
Thank you for having me. It's been a real pleasure speaking with you.
Hi, everyone. That's it for this week's episode of the FinTech Blueprint. For more technical deep dives into all things fintech and decentralized finance, check out fintechblueprint.com and grab a free subscription to the newsletter. This is Lex, and I'll see you next time.